So just a very quick introduction to who we've got on the team representing Seiki this morning. We've got John Davis. John, you can give everybody a wave. He's on mute at the moment.
Good morning.
Morning, John. John is our managing director. We've got Neil Saunders, one of our account managers. We've got Martin Chu, who we can't quite see at the moment, but he's our machine connectivity expert. And we've got Wayne Lawrence, also one of our account managers. So hopefully you've met at least one of the team already. And I'm Damien, I head up marketing within Seiki. So hopefully you can all see my screen, and because half an hour goes incredibly quickly, we're going to make a start for today. So machine monitoring. Oh no, good start, Jamie. Trigger happy. Okay, so
as they say, slow down.
Yeah, that's all right. I'm trigger happy. So some of the common challenges that I'm sure will be familiar to all of you, one or all of them. I'll give you a minute to have a read through of those, but these are typically some of the things that people come to us to look at a machine monitoring solution as a means of tackling some of these issues. So are you having problems getting consistent data from all your machines? A lot of people have different types of machines within their factory. So getting a consistent set of data out of them and one view that you can analyze can be a bit of a challenge. And you don't have time to constantly walk around the shop floor to see what's going on. You know, you want real-time data and you need something to measure whether you're having a good day or not. What is a good day? So with machine monitoring, hopefully we can help answer some of those questions and resolve some of those issues. Oh, the double click is happening today. Let's go back. Okay, so we often refer to machine monitoring as a quick win. Why do we say that? We say that because as soon as you connect your machines and you'll start collecting that data, you should immediately start to see some information that you can actually work with. So immediately you'll see, are your machines running or not? That might be a surprise to you. You might have the expectation that they're running not all of the time, but they're running a lot of the time. And the performance might actually be lower than you expected, or sometimes it happens, it's the converse of that. But you will also instantly, where we're automatically connecting to your machines and picking up those alarm conditions, you're going to see as soon as they go into an alarm condition. So you're going to be able to start responding instantly to any downtime that's caused by, critical stoppages. As part of the installation process, we give you training and teach your team how to enter downtime reasons. And so within 24 hours, you will start to see, based on the feedback provided from the shop floor, some of the causes of your downtime. You'll also, we would expect to see a lot of unknown stoppage time as people start to ramp up and get used to using the system. Sorry to the Seiki team, if you could just admit anybody that's still joining us, please. You'll start to see some of those unknown stoppage times, and we will, obviously over time look to decrease that and get into the granular detail so that you can start to understand what your problem areas are. And that will really start to emerge over the next month or so. So you'll start to see some trends and dig into those areas of significant productivity loss. And then beyond that, we're not talking over huge amounts of time here. You'll start to see some areas where you probably didn't have visibility before. So anything that you hadn't been able to track before will start to emerge, and you can really start to analyze that. So we're not talking large timescales here. And our approach to all of this is actually pretty simple and can be encapsulated by this 3 C's term. First, connect your machines. Oh, trigger happy. Let's keep it on the screen. Then start to collect some live, accurate data from those machines, and also from the shop floor with your operators manually inputting downtime reasons. And then use that data to continuously improve. And you're using accurate, up-to-date information that's happening as live on the shop floor. So you're not working to any irrelevant or legacy data. Oh, trigger. John and Martin, I'm going to hand over to you at this point, if that's okay, and we'll talk about how we connect to those production resources.
Yeah, thank you, Jamie. Hello. The screen in front shows
typical connections we use to talk to CNC machines of varying age. We have software connections, MT Connect, OPC. These are through Ethernet connections. And we also have digital I/O connections through I/O device, where we pick up a machine tool's outputs to trigger the statuses we use. On some older machines, less complicated machines, we even have a more basic sensor approach where we can pick up typical current from parts of the machine. Next screen, Jamie, please. The display in front shows slight differences between the types of connections, and the small blue and white device is a typical I/O device that we fit inside a machine tool. And you can see in the panel display. The darker colours, the running, alarm, power on, and part count, they're achieved through this hardware digital I/O device, whereas the slightly lighter blue, feed old, rapid feed, etc., are the typical things we pick up through the software Ethernet type connection. Listed at the bottom, you can see there's the connection methods typically for FANUC machines using FANUC Forecast, MAZAC using Cyber Monitor, and then MT Connect for a range of machines, but typically Siemens, DNC option 18 for Heidenhain, and then OPC, which is becoming a very popular connection for quite a wide range of machines. Sorry, Jamie, yes, please. The next screen, please. This is going back through our history. We've been doing it for a while. It's not a total list of machines, but as you see, it's a fairly extensive one that covers most common that you'll probably find on your shop floor.
It's not the most exciting screen slide that we've ever presented, but I think, as Martin says, it just gives you a good idea of the breadth of machines that we've connected to. And Martin's done pretty much all of those, I would suggest. It's
yes.
Commonly found on shop floors around the UK.
If I could just chip in as well, correct me if I'm wrong, Martin, but if we're doing digital I/O, so we're not talking to the machine via software, then the machine manufacturer or maker model is more important. If we're doing software monitoring, it tends to be more the control maker manufacturer that's more important. Is that fair? Absolutely.
Absolutely, yeah. Yes. The control is the software connection, whereas the machine tool, a supplier will buy a control and adapt it to their machine. So the digital I/O is talking to the physical electrical side of the machine and not the control.
So on the next slide, it's probably worth opening that up a little bit wider, is talking about that machine connection architecture and the kind of things that we're looking for, and that sort of our expertise can bring to the table. I think, John, you were going to take this one, sorry.
Yeah, so this isn't intended to be a tech heavy session. If there are any IT people, then you'll probably be more interested in this slide than any of the rest of the audience. But the reason that we've put up this architecture diagram is more to talk about the machine connectivity. So as Martin says, we've been doing this for quite a while, in fact, over 30 years now. And we've a lot of experience of connecting to machines. So you will have companies, and some of those will be not UK-based companies that may offer you a solution that you can connect over the internet, and that's perfectly feasible. But you will find that you will end up with a lot of the responsibility of configuring that IT infrastructure, so those machines or the devices that company may supply, so that you can actually collect the data. So the data, these examples down here where we've talked about MAZACs, FANUCs, Heidenhains, they talk on different ports, they use different connection methods. Some of them just need an IP address, some of them use a UDP port, some of them need a web address such as MT Connect, so we're almost talking to a website. And then we've got the physical, this EH is electrical hardware device, this is where we're fitting the devices into the machine, and we have various devices that we can use. So I don't want to bore you with the technical detail, but it isn't necessarily plug and play. We would work with your IT department or your third party IT providers, if you have people external to your company, and we can set all of this up in the background that's really invisible to operations. So when Martin comes in, as an example, if it's Martin, if he connects up the machine, we've got the infrastructure in place so that we can then deploy the system. So it's really just as much as anything to demonstrate our expertise and our knowledge over many years of what we actually need to do to actually get that system working for you.
And I think that's also explains why we ask for things like a machine checklist when we in advance, so we can, review that and just see what our options are for connecting to that machine. Yes, exactly. So we've looked at how we connect to the machines. Let's talk a little bit about collecting some data from them. So not just as we saw there with the automatic data capture directly from the machine, but we also ask you to and give you the ability to define your status grid. So defining downtime codes that the operator will select from to identify and help you analyze why the machines aren't running. So how you define your states directly impacts the type of analytics that you will have and the kind of answers that you'll get from your system. So we go through a process with you through the training so you can understand, how the system works, but to start making you think about how you're going to define your grid. And then we'll do, as standard, a follow-up configuration session with you, typically half an hour to an hour, and we'll walk through that grid and we'll make sure that you're comfortable. We'll go through and make sure that you've really thought about what's going on there to start with. And it's really important that you share definitions with all of your team. Seiki AIR is not licensed by user, so you can actually put this information in the hands of everybody that needs it, which is particularly powerful from an analytics perspective. But that also means that everybody needs to understand what data is being captured, what it means, and their role in sharing it. It's that clarity and transparency that's going to be the key to your success. So we also talk about involving your shop floor team in this process, because they're really the people that understand what's causing the productivity loss. They're there at point of event and they're the best people to feed back. So we want them to engage, and it's very useful to get them involved in defining your grid. And it also there are other things in the system, like we provide the utilization feedback to the shop floor users as well. So there's this kind of continuous improvement process where they can help support that. So there are a few ways that we support accurate and consistent data capture. We use monitoring logic to help ensure that procedures are followed and that prompts are sent to users if they need or have forgotten to enter downtime reasons, or if a threshold has been exceeded, for example, on a status type, or timed threshold, I should say. We also send out real-time event-based notifications, so as things happen, because there's no substitute for correct data entry at point of event. And the other thing here is about, whilst we do connect to machines to pick up data automatically, extending the machine monitoring system to your manual resources as well can be very powerful, because it means there's no blind spots in your visibility of what's happening on the shop floor, and the data that you're receiving back from the shop floor is consistent. It's working to the same downtime codes, and therefore your analytics can be much more informative for you. So collecting all of this information is great, but you really need to use it to make it work hard for you. So this process of continuous improvement, which you'll all be doing all the time anyway, is about agreeing how the information is used and using it regularly. So as an example, every day somebody should be monitoring the live status screens to see what's happening at any point on the shop floor, so you can respond quickly to any downtime causes. Include the screens and the reports in your KPI review meetings every week, and use those, the feedback that you're getting to identify actions for the next 2-3 weeks to make improvements. Review quarterly to analyze trends and identify strategic actions. One example I had from a customer recently, it wasn't the biggest investment. Well, it's £10,000, it can be significant, but they recognized that they were losing about £3,500 a week waiting for a counting machine to be available. They got this through their analytics data. They spent £10,000 on a new counting machine and it paid itself back within a month. So you can use your data to make smaller or incremental changes that can actually make a bigger difference. Use the data to help you identify and make decisions about investments. This could be as part of your budget review every year. But you should also regularly review your status grid, because as you start to tackle issues and minimize the impact of any downtime causes, there might be other things you need to focus your efforts on. So that's why we give you such a flexible grid, that you can take control of that and make it and tailor it to what's actually happening in your factory at any time. Has any of the team from Seiki got anything to add? Because I think we're about to go into demo mode otherwise.
No, I think you've covered everything, Jamie. There's nothing I'd add.
Okay, so at that point, I'm going to hand over to Neil, and he's going to give you a demo of the monitoring system. Oh, Neil, you're on mute.
Yep, gotcha. It's okay.
Thank you.
Just share my screen. Hi, morning, everyone. So what I'm going to do today is give you a brief overview of the monitoring system. It's by no means a totally in-depth view of it. It's just to give you a flavour, and we'll be more than happy to talk to you and show you all of the features and benefits you can get from it. So we're going to start on the shop floor screen. If you were monitoring only, you wouldn't get the right-hand side. This is our WIP booking module, but it can be used to enhance both the analytics data and the monitoring data if used in conjunction with the monitoring. So at the moment, we're on the Mazak machine, and we're in a setup state. Within the system, there's a couple of statuses where we just need to tell it that it's completed, because if you are in a setting state, or the other one for this is maybe a maintenance state, we don't want it going picking up production running if you're automatically picking up signals from the machine. So in these cases, we just have to tell the system that we've completed our setup. So normally when
Neil, sorry to interrupt, and I don't want to mess your flow, but you're still showing the work queue. Shouldn't we be on the utilisation screen? Because you said the work queue is not applicable to monitoring systems, and this is monitoring.
I'm on the shop floor.
Yeah, on the work queue.
Only license.
Yeah, but you can click on the utilisation tab.
I can, but I need to access around here. So
okay, I'll let you go.
No problem. So at the moment we've gone through the setting state, and the next logical step would be to request a first off inspection, or to send it to first off inspection. So here we can select our matrix, and we can then request first off inspection here. And if I click it, you see that the monitoring changes to go off to first off inspection. So we would then wait and see whether we've passed or not, and when we've been given the go ahead, we can then carry on and put this machine into production. So I've got a simulator here that simulates me going into a productive state, and what will happen when I click the button, it will change the status to production running or in cycle, or whatever it is that you've decided to call that particular state. So when we run through the cycle, we come out at the other end, and as we come out of cycle, you see it goes to this pause state. That's a dwell time that we can allow to let the operators time to clean off fixtures, blow off jaws, put the next part up, and maybe put it back into production. Mine's set fairly quickly at like 10 seconds, but normally this could be varying from a minute to 5 minutes, so it's something that's agreed with the customer. And what you can see now has happened that because I've not gone back into a production state, it's gone to this unknown stoppage. And also pop me up a message to say that we're in this unknown stoppage state. Now, the last thing we want is a lot of unknown stoppage, because it doesn't help us to analyze what's been going on the machine. We can't identify that downtime reason. So here, the operator can either say, yes, I want to put in a reason now, and they can go to the matrix and enter the reason for the unknown stoppage. They could ignore it and click no, or maybe they select a different machine, and so we come off of it. Maybe they're multi-manning, for instance. But the great thing is that we have the ability to retrospectively put in a reason for that unknown stoppage. So when the machine goes back into cycle, if you look in the top right corner here, you will see that a new notification message appears. And if I then go to my notifications icon, we can see that that message there is the unknown stoppage and the duration that it was in it. Mine was fairly quick. So I can now set the status of that unknown stoppage. So I can access my matrix and I can select the reason why. So it could be I've been putting some coolant in the machine, or I'm changing some tooling, or maybe the multi-manning reason. I've had my head in this machine and the one behind me that I'm running also has stopped and I've not realized it. So I'm going to select multi-manning. And what that does is it then moves the time from that unknown stoppage to multi-manning. So we've now collected the real reason as to why it's not running. So we carry on collecting all of this data, and then we can look at the analytics in the back office. So we have...
Sorry, Neil, I've just got to come up. Can you go back to the shop floor, please, and show people what they would see if it was monitoring only by clicking on the utilisation tab?
Sorry.
Thank you.
Okay.
So that's what people would be looking at, not the work queue that you've been displaying. And maybe just pick the current shift because you've got a lot of out of shift time. Thank you.
Yeah, sorry about that. So yeah, so this would be the screen that the shop floor can see if you are on a monitoring only system. So back to the analytics, we have these live screens and the dashboard. So here on the dashboard, we've got a list of our resources that we're monitoring on the shop floor. We have color coding next to them to say whether they're in a production state or not. So green is production, blue is waiting, cyan is inspection, these sort of things. We can also see the status, and we can also see the last user that interacted with it, who was logged on and interacted with that resource. We would see the utilization either over the last 7 days or the current day, depending on what you'd like to configure it to. And we've got the black line here, which is our target. So we can set a target of our utilization that we're trying to achieve, and then see which resources are achieving that or bettering it or are under it. So we can then see also the utilization percentage here. You would then get a bullet chart here. Mine's a little bit peaky and trophy because it is a demo system. I don't run this day in, day out as you would do a resource on the shop floor. But what we'd really like to be seeing is an upward trend. So again, I've got it set to the last 7 weeks. It could be for the current week. And we will want to see an upward trend to say that you're actually improving your productivity on those machines. So you've been spending more time in production. So all of the left-hand side here is monitoring only. Ignore the right-hand side again, because that's to do with the WIP booking, where we can actually see what jobs we're booked on. So monitoring only, you would get this part of the screen. And as I understand it, tell me if I'm wrong, but we're going to get some more columns and selectable columns in these screens in future releases. So then we can look at our historic analytics. Oh, sorry, before I do that, let me show you some other live screens. So timelines, we've got like a DNA type chart where we can see what's been happening. We can zoom in a little bit on this. So we can then select what status it's in, and it will tell you those status and how long it's been in it and the duration. So we've got like the DNA chart of what's been happening for the events. We have the and-on screen, which we can then display either all resources or a resource reporting group, such as your lathes or your mills, or maybe a cell of machines. You can have this in your production office on a large screen, or you could have it over cells on the shop floor or out on the shop floor for people to also see. Again, we can select today or the current shift. We can see how well we're performing. And if I change this, you would see on the Mazak here, if I put it into an alarm state, you can see it's interacting live with what's happening on the shop floor, and the dashboard will do the same. We can then look at our historic analytics. So again, if I pick, let's say, the last month, we can then see how well we're performing by how productive we've been. So we were 46% productive on all shifts. So I can select shifts, or I can select machine groups again, or individual resources. So I'm looking at, for the last 30 days, all shifts and all resources. So I can see my productivity, which is great to know, and it's important. But then from around about 5 o'clock around to midnight are all my losses. And this is where the strength of the system really comes in. because now we can start to look at those losses and start to put in measures to reduce them. So if I select my waiting time pie, I can then see all of the sub-statuses that have been booked under that waiting time section. So my worst waiting time is not having any material ready, not having a set as my next, waiting for a previous operation. And you can see the percentage of what it's affected and how many hours you've lost basically waiting around for these things. Another one might be inspection. First off inspection can tend to be a bottleneck in most companies, and we can actually quantify how many hours are lost for first off inspection. And an example of fixing that is someone employed another inspector and they actually gained a 10% productivity improvement across all their machines once they quantified the losses of waiting for that first off inspection. We can view it in other ways. We can have a Pareto chart and again drill into our sections. We can view the top 15 losses. So you won't have any production here. It'll be the top 15 losses and you can analyze those again. We can look at trends such as maybe maintenance and maybe the breakdown mechanical and highlight up that trend. And we can also analyze how well different resources are performing by putting them together. So for instance, here I might want to analyze my lathes. And then I can see all of the different statuses that have been booked, but I can also group them by that status. So I can now see that my Doosan was my best performing lathe, the best for production. My worst was the Citizen. My worst for waiting was the Citizen as well. And unavailability, the Mori. So I can start to look at that and look at that either on all shifts or specific shifts like day and night shifts and start to compare how we're performing. So hopefully that gives you a little bit of an overview as to how the system comes together. Like I say, it's not in depth, it's not covering everything, and we'd be more than happy to speak to you in the future when you're ready to go through it in more depth with you.
Thank you, Neil. Thank you very much. Okay, I'm just going to share one more screen and then because we're coming to the end of the session already, I'll say it goes very quickly. I think John's just going to introduce the concept of OEE as a next step as well in terms of taking your utilisation data further, and then we'll open the floor up to some questions. So John, if you're happy to just take this screen.
Sure, yeah. So we've talked about machine monitoring. So if we're monitoring the machine, we're looking at the machine 24/7. Even if it's turned off, we know we've lost connection to it, so we can capture that time as well. People can get quite focused on the utilization of their machines and keeping that utilization high, but that potentially can mean that you're not particularly running the machine very effectively. You could be a busy fool. And I think we've been doing this a long time. I've particularly been doing this a very long time. And if I turn the clock back maybe 10 years, you wanted to keep those machines running. You wanted to report to higher level management that those machines were well utilized. But I think nowadays people have less of a team normally on site. You need to make sure those machines are running effectively. And that means not only are they running, but they're running, producing the product in the time that you expect. And also that they're producing good quality product and rather than non-conforming product. So you can extend the machine monitoring and use OEE, overall equipment effectiveness. Some of you may be familiar with this, some of you may not, but essentially it captures three factors. It captures the utilization that we've seen from machine monitoring. In OEE speak, this is called availability, but it will also show you when those machines are running, how much of the time they've been running effectively, as in producing products in line with the standard time. And thirdly, of the products you're making, what percentage of those, what quantity of those products are non-conforming, or alternatively, looking at it a different way, how much time are you spending making non-conforming products? OEE has traditionally been used in process industries where the factor can be quite high. You imagine if you've got a process line, maybe churning out little washers or nuts or bolts, or that you're filling milk bottles or Coca-Cola bottles, that machine may run 24/7. and have very little downtime, so you can get very high OEE. That's much more difficult to achieve with CNC machines unless you've got multi-pallet machines or an FMS cell. So I just want to share, and I'm going to share just one screen. So this is a live system, but because the data has to be meaningful, I'm just going to show you one screen. So if you can see a screen at the moment, it tells me that I've got 56% OEE. This actually, I've deliberately set this back at a date last year when we ran a webinar specifically on OEE. And whilst my machine utilisation, which is the dial you see at the bottom, is 67%, that would be exactly the same to the utilisation I'd see in machine monitoring, other than it's removed an amount of time for any planned stoppages. So in my case, and I'm not sure if you can read the numbers on the screen, but we've got 76.5 hours on this day for all of my CNC machines, but I only expect them to run for 75 hours, 45 minutes, because I've got about 45 minutes of planned downtime, for example, planned maintenance. But that in effect is what I would get from the machine monitoring. Other than the planned downtime, I'd get that same number pretty well. But during that time that my machine is running, which were about 50 hours, I've only been effective for 44 hours. So I've only got 87% performance. So this is looking at the products I've made compared to the standard time on those products and how much time my machine has been in, or my machines have been in production producing that product. And then finally, of the products that we've manufactured, 95% of them were good. So 60 out of 63, but 3 parts were non-conforming. So you can start with machine monitoring, but you can add OEE with the performance and quality. And there's 2 methods you can use to book the data. One is the work queue that Neil showed you previously, where you actually book the works orders and the operations that you're producing. Alternatively, a simpler method, and this requires no integration to any third-party system, is the operator purely indicates the product that they're making. We don't need to know the planned batch quantity. All we need to know is the product that they're making. In the database, we've held the standard times. But the other solution that Neil showed you with the work queues is where we'd normally integrate to maybe your ERP or some other system where you hold your works order data, and we'll pull in all of the standard times and orders and operations, and people can book down to works order level. So it's something that you could extend your monitoring solution to, either on initial implementation or at some point in the future if you wish to.
Right. Thank you, John. Thank you so much. Right, I know we are running now a little long, so apologies for that. Thank you for sticking with us. I'm just going to throw this open to questions now. So we have reached the end of the presentation. So if anyone has any questions, please do use the comments or shout out. I'm also going to launch a poll that's just going to ask you a quick question. It'll appear on your screen and in the chat, just asking if any of you are currently measuring machine utilization or OEE manually in any way. But yeah, so over to the audience then, if anybody has any questions.
If you have any questions, just bear in mind you're on mute at the moment, so by all means, but don't be afraid to shout up, or alternatively, if you wish to put something in the chat, you can do. And if we'd ask if you could complete the poll, if we get a number of responses before you drop off, then Jamie can show the results of the poll, I think, yeah?
Yeah, we can do. We're currently sitting about 70% that people aren't currently measuring anything manually, either monitoring or OEE. I'll keep an eye on that if it changes. We have a question that says, and I'll open this up to anyone that wants to answer from Seiki, can you define the unknown stoppage threshold against specific jobs?
Currently, the answer is no. All of our development is really prompted by customer requests, such as those that you've mentioned, Jonathan. Sometimes they're quite individual to the customer. The generic ones tend to get prioritized. So I'm guessing what you're thinking is you might have an unknown stoppage that could be a load unload time, for example, and you'd want that to be product specific. So that would be a natural enhancement to the system. We don't have it currently. I think the reason that we've not added it is because people wouldn't necessarily have that data available. You might have setup and runtime, for example, in your ERP that we could import, but would you have a load and unload time? I don't know, Jonathan, if that's behind your question, but I wonder if it might be. So currently, no, the unknown stoppage threshold is system-wide.
Thank you, John. Any other questions?
Hi,
Hi, John.
I just want to ask a question about we currently, and I'm being truthfully honest on this, we have a lot of we do use OEE to a level. We also use machine monitoring in regards to people. So they're telling us against shift time how much time and how many problems they have. We're very skeptical about some of the information that's coming back. So I'm just wondering on this system, how much of this percentage-wise is likely to be operator input as opposed to machine monitoring, automatic machine monitoring?
I can see John preparing to answer.
No, I wasn't. I
was
thinking Jane was going to answer this.
Okay.
I don't mind chipping in a little bit.
Go on, please do, Martin. Yes, go.
Hello. Machine automatic monitoring is obviously dependent on the CNC machine tool telling us what it's doing every moment of the day. So the automatic side of it is not adjusted by manual. The manual input, if your guy is late putting data in, as you've seen, there's unknown stoppages, you can go back and rectify it. If you are collecting now manually, I always tell people that human beings work in 5 minutes, 10 minutes, 15 minutes, 30 minutes, and an hour. They don't record 17 minutes, 23 seconds. And that's nobody trying to pull wool over anyone's eyes. It's just people don't work in such small increments. So now, John, you can add your bit if you wish.
Well, I was just, but building on what Martin said, really the system collects data automatically when the machine is running. And unless it's an alarm condition, generally CNC machines don't know why they're stopped. So that's where the operator needs to input the reason why. But what you will have, as Martin says, is you'll know that 17 minutes, 23 seconds is because the operators had to change a tool, for example, which if they filled something in manually, they might put half an hour, they might put 15 minutes. And the data, just going back to the data that Neil showed you, when he expanded that waiting time, he lost 22% of his time for waiting, but no single reason was more than 4%. So we're not expecting you to use this system to suddenly find 20% of downtime for one reason that you didn't know about. I'm guessing you know that. A lot of it is the custom and practice. But if all of those 2% and 3% and 4% add up to 22%, you've got a good chance of getting that sort of increase in productivity by making quite small changes. So the operators do need to input the reasons for stoppage, but we try to make it as simple as possible, as intuitive. But the final piece is the people that are using the data need to use the data effectively, and the operators need to have visibility of that. The collecting the data is a necessary evil to give you a dashboard, to give you KPIs, to improve your OEE. So if you're going to use the system, then the operators need visibility. And if you're lucky, and you can't always get this, but if you're lucky, you get a quick win. So you find something and you change something that generally makes the operator's life easier, because if the machines are running, it's much easier for them than when they're having to deal with issues.
And I would just add one other little thing, if I may, is that we use the prompts and notifications on the screen as well to try and help get into those good practices of entering information on the shop floor. So things like a machine is running without an active job. If you're doing OEE, then those kind of things will help try and reinforce that data capture.
So that capture of input from the operator means that there's a terminal at each machine, does it?
Not necessarily, no. AIR is browser based. That doesn't mean it's hosted on the internet. It just means it's installed. It can be installed locally, but you just need a browser on a device, a laptop, a PC, a tablet to access the system. Okay. And that means that you don't have to be stood next to the machine. You don't have to have a terminal per machine. You've got a lot more flexibility with AIR.
Okay. I would say the number of terminals, and it varies a lot with the, obviously, IT hardware has come down a lot in price from 10 years ago, when you probably pay, significant money for a PC. You can, as Jamie says, use a tablet. We have several customers, a good number of customers using tablets. If you've got one person running, say, 2 or 3 small lathes, And they might even have a bench between around those machines. They might be in a sort of U-shaped formation. Then you'd probably have one tablet on the bench. If you've got a larger machine where the operator's going to have to walk quite a distance to get to the tablet, you'd want a tablet on every machine. It depends how often also the operator's got to go to book the downtime. So if you're working on quite long cycle times, they're less likely to have an issue every few minutes or every half an hour. Whereas we've got customers making, in quite short cycle times, in which case the machine can be stopping every few minutes, in which case if they have to walk some distance to a tablet, then you're going to get a lot of unknown stoppages that people have to rectify historically. So it sort of depends on the environment, and we're happy to give you the benefit of our experience if we were to sort of physically look at your plant and layout and understand your environment more.
It's also, Peter, it's also worth mentioning that obviously you don't pay, it's not per copy anymore, so you can have as many as you want without any financial penalty. And obviously you can always add to them. So if you find you start with 3 or 4 PCs or tablets on the shop, and then you're getting some feedback that the tablets are always in use, you can just simply add another tablet. There's no software cost. It's very simple to configure. And obviously it's only the cost of the tablet or PC that you're adding that you'll incur. So it is flexible.
Just to clarify what Wayne means by per copy, he means per user. We don't license per user, it's per resource license.
So understood. But what sort of return have you've been doing this for years? What sort of return going into a 15, 20 machine workshop? What sort of improvements, what sort of return have you got for this installation?
It will depend on how efficient or productive the customer is initially. There's certainly 1 or 2, I guess, that we've installed over time, and we do feel, well, maybe when you've purchased this system, you could have found some of this data even without the system because it is so poor. But I think most people would be looking at figures, double figures, certainly 10% plus. Possibly more. The higher return, the higher the improvement you get, then the less effective you are in the first place. In terms of return on investment, it depends on the number of shifts you've got, the number of machines. So if you're double shifting, your return on investment is going to be halved in terms of days, weeks or month. But most of when we've run a return on investment calculator, depending on the hourly rate you run your machines at, whether it's £60 an hour or £80 an hour or even £100 an hour plus, I think Neil and Wayne would also run these. I don't think we see many that are in excess of 3 months for machine monitoring, or even quite small improvements in efficiency. So if you got a 5% increase in utilisation, with most customers, you'd see that it's probably paid 3 to 6 months. If you're double shifting, I'd say 2-3 months would be quite common. If you're single shifting, we might say it could be 6 months to get a 5% return on investment. I don't know, Neil, Wayne, whether you share those numbers, but I think for the ones that I've done, I probably think that's about right.
Yeah, I always
run. Go on,
sorry, Neil. I was going to say, I always like to point out that as little as 2% increase in productivity and your system's paid for itself in 12, 18 months. So like John says, if you can get 4 or 5% increase in productivity, which we would absolutely expect at most sites, then your system's justified itself within 6 months. And obviously you're going to be using a system for the next 5 to 10 years. So you'll effectively, earn money by increased productivity over that time.
I would say it's a bit less than that even, because when I put the ROI in, if you make a 3 to 5% productivity improvement on 15 plus machines, it normally comes out that it's under 12 months for the ROI for a small increase in your productivity.
And can I add, I had a real case scenario of a machine shop with 12 machines. 3 machines were identical. They were Fanuc robo drills. This company had no spare capacity, did not have spare cash to go buy a new machine to make them any better. But due to monitoring, they found that the 3 robo drills were being used totally inadequately, to the point that one of those machines came free. In about 6 weeks, they realised that. And they already, of course, had that machine, the operator, the tooling, the electric, the compressed air. It was a free-to-use machine.
Interesting. Thank you, Martin. Any other questions? I can see someone's typing currently, so we'll just wait to see what comes through. I do appreciate that everybody stayed on a lot longer than planned, so hopefully you're finding it useful. Let's just wait for this last comment.
Just while Douglas is typing, Jamie's now published the results of the poll. I hope you can see that on your screen. So 27% of you that are recording this manually, if you feel we can help improve the accuracy of that data, then please, we'd be delighted to talk to you. And the 73% that aren't doing it manually, I don't know if that means you're already doing it automatically, but on the assumption you're not doing it at all, then maybe this has given you some food for thought. And again, we'd be delighted to discuss further with you.
And I'm not sure if there is going to be a question, so just in case, I will obviously follow up with everybody. I'll make sure you get a recording of the session from today to refer to. Neil and Wayne will be following up just to see your thoughts and see if there's anything you'd like to see further. And I think we're going to call it time there today, everybody. So thank you again. I hope it was useful. It was nice to see you all, and have a good rest of your day.
Yeah. Bye.
Thanks very much, everybody.
See you later. Bye.
Take care, everyone. Bye.